Good morning. Today we are continuing to work with fractions. We are working on Po16. I can add and subtract fractions. So imagine for a moment you are a zookeeper. I know it's a stretch, but just bear with me. Mr. Schultz is funny. Your zoo has recently gained a bunch of animals from a nearby zoo that closed. Would you add lions to the pandas? No. Would you add gorillas to the penguins? Of course not. Would you add tropical fish to the giraffes? Well, that would just be crazy. This same logic can be applied to adding denominators of fractions. So we don't add unlike denominators. It doesn't make sense. So when adding or subtracting fractions, we follow the same basic rules. Number one, denominators have to be the same. So we want to make sure we have the same denominators. When we do that, make sure whatever you do to the bottom, you do to the top. So remember, if I'm multiplying the bottom by 3, I have to multiply the top by 3. It's that same scale factor. Lots of times people just multiply the denominator and leave that numerator alone. We are making equivalent fractions. Then we add or subtract the numerator. Denominators stay the same. So you only add or subtract the numerator. What do you think our final step is going to be? What do we always have to check for with fractions? Rhoda, can I simplify? So we always have to check, can I simplify? Simplify, simplify, simplify those fractions. Final step. Okay, so we've got those 3 basic steps. I like to throw on that simplifying as the third one. So think of a denominator as telling you what you have, and the numerator telling you how many you have. I have 5 penguins. Okay, so that penguins would be the denominator. 5 is how many. That's the numerator. Also, we can look at that with tables and chairs. I have 2 chairs plus 3 tables. Does that equal 5 tables? No, that's just silly. So just like 2 sevenths plus 3 ninths would not equal 5 sixteenths. You can't add penguins and giraffes together. You can't add tables and chairs together. We have to make that denominator the same. So let's look at how we do that. Let's look at an example. So you must show your work and you must simplify. That's why I put number 3 as simplifying, because we always have to simplify our answers, whether it says it or not. We know we simplify answers. So our first row is kind of easy. What makes that top row easy? Alex? They already have the same denominator. So you are only adding or subtracting your numerator. Denominator stays the same. So 1/5 plus 3/5 equals 4/5. So there's not a lot of work we have to show for that one. I always have to double check, can I simplify? Can I simplify 4/5? No, there's not a number that I can divide out of the top that I can also divide out of the bottom. So we're not going to work through that top row because that's the easy ones. Okay, let's look at yeah, you get to do that one on your own. So you're going to do your 6, 7 on your own. God bless Mr. Schultz. Let's look at our second row. 1/3 plus 2/5. What's my first step, Joy? Yep. Yep, so remember, we are multiplying by that same scale factor. So whatever I do to the bottom, I do to the top. Why did you pick 5 and 3, Joy? The closest multiple. Yeah, the closest multiple that they shared was 15. 3 times 5 is 15. 1 times 5 is 5. 5 times 3 is 15. 2 times 3 is 6. Now here's the important thing, because on the test I always have people forget to look at the operation they're doing. Notice how we have both adding and subtracting in this subjective. On the test you're going to have adding and subtracting, so you have to double check. I always have people accidentally add when they were supposed to subtract. So always rewrite your operation. So now I have 5/15 plus 6/15. What does that equal, Haley? 11/15. We only add or subtract our numerator. Denominator stays the same. What is my final step? Michael. Yeah, can I simplify it? Can I simplify 11/15? Joy is giving me a thumbs down. There is nothing I can subtract out of 11, or sorry, divide out of 11 that I can also divide out of 15. So I cannot simplify that anymore. Let's look at our next one. 8/9 minus 5/6. Joy. So Joy is looking at that and she's saying, okay, I know that they both can go into 36. So that is a common denominator that they could share. 9 times 4 is 36. 8 times 4 is 32. 6 times 6 is 36. 5 times 6 is 30. Double checking my operation. I am subtracting this time. So what do I get from 32 36 minus 30 36? Joy? Joy looked at that and said 236. I can simplify that because they're both even numbers. So you can divide a 2 out. 2 divided by 2 is 1. 36 divided by 2 is 18. I can't get any simpler than that. Now, is 36 the only common denominator that they share? No. I could have gone all the way down to 18 and said, okay, I'm going to multiply this one by 2's. So that would be 16 18s, and I can multiply this one by the 3's. So that would be 15 18s, and I subtract, and I would get that 1 18th. I could have said 9 times 6 is 54. So I could have just multiplied those two denominators together if I wasn't sure what other multiple they shared. So 9 times 6 is 54, so 8 times 6 is 48. 6 times 9 is 54, so 5 times 9 is 45. And then I would have gotten 3 over 54. Then it gets hard, though. I don't know my multiples of 3 all the way up to 54. I'm not sure if I can divide out. It just gets more complicated the bigger you get. So while you can just multiply the two denominators together, you end up with really big numbers, and it gets more tricky to simplify. I always try to find smaller multiples, lower multiples, that least common multiple, so I don't have to simplify as much. But any of these would be correct because they all simplify down to 1/18. So you get the same answer no matter what common denominator you use. It will simplify down to the same answer. So it's going to be correct as long as you simplify it correctly. Are there any questions on those? All right, on the bottom, you have some word problems. What two fractions with different denominators add to be 9/20ths? And what two fractions with different denominators subtract to be 9/20ths? So we want our answer to be 9/20ths. And I want to be able to add. What I like to do is I like to keep one of my denominators to be at that 20. And then I take another denominator that I can easily make 20, like 10. So I have different denominators. If I said, let's say 6/20ths, any guess what I would put as my numerator for the 10? Matt. Why 3? Because you're thinking 6 plus 3 equals 9, but uh-oh. Remember, I have to do what to my 10 to make it a 20? I'm going to be multiplying that by 2. So what? You're right that that's going to be a tricky one. Let's do 5. If I have 5/20ths, now can you figure it out, Matt? How many more do I need to make 9? 4. So what can I times by 2 to make 4? 2. Because I know 2/10ths is the same thing as 4/20ths. So I can break it down. So these would be my two fractions, 5/20ths and 2/10ths. I know it's the same as 5/20ths plus 4/20ths. That's going to equal 9/20ths. You're going to try to do the same thing with the subtracting. What two fractions can you subtract to make 9/20ths? Okay. Any questions on our math for today? All right, remember, you can come check with me to make sure you're getting the correct answers. If you do finish before class time is over, math packet, Khan Academy. They are both due on Tuesday, but if you turn that math packet in by Friday, you'll get it back to make fixes on it. Memorizing the mysteries of the rosary. Okay, so we do math and theology first. If you are all finished with all of those, then check in with me. All right, so do your homework, math packet and Khan Academy, and then mysteries of the rosary. If you are watching this at home, I hope you are well. And I hope to see you soon. Have a wonderful day. Don't forget to like and subscribe.